And so without further ado, we're going to move from left to right. I'll introduce our panel. To my right is Dr. Joe Dojcik. He's the Associate Director for Aerospace Technology in the Office of the Secretary of Defense, Acquisition Technology and Logistics. He's tremendously experienced and has many high honors to his credit, and I won't go through them all because, as I mentioned, we have an hour and we have a lot to say, so I'm going to keep the introductions brief, but it's a very distinguished panel, and many of you probably know these folks. To his right is Ned Chase, who is at the Aviation Applied Technology Directorate, part of Army's R&E Com, and he serves as the Future Vertical Lift S&TIPT leader. To his right is Mike Fallon, who is the Assistant PEO Rotary Wing for Science and Technology, and is the rotorcraft Science and Technology Portfolio Manager for the Navy. And to his right is Dr. Ashish Bagai, who is a Program Manager at the Tactical Technology Office at DARPA, and he manages the portfolio there for vertical flight technologies. So we can get into all of the great content that we have today, and our folks have some slides, so we're gonna walk you through some charts and some good stuff. I'll turn it over to Joe.
Thank you very much, Andrew. Thank you to CIS for sponsoring the event and for inviting us here today. I'd like to leave you all with the opportunity to get a perspective on the broad S&T that DoD performs, and then again how it relates specifically to rotary wing vehicle, future vertical lift. Next chart, please. Just make sure I'm in the same chart. So as Secretary Carter has stated, we face unprecedented challenges these days. The U.S. warfighter now has to deal with near-peer adversaries, where in the past we really had the luxury of being head and shoulders above our potential adversaries. Not only are there budget challenges in terms of reduced budgets, but there's also budget uncertainties. That makes it very difficult to plan to address the multiple scenarios that the warfighter has to face. From a technology perspective, cyber, space, the EM spectrum, all of those are changing at a very rapid pace. And geographically, with these threats, we also have the tyranny of distance. And as a result, anti-access area denial, for example, in the Asian Pacific is a very huge challenge that we face. Next chart, please. So to address that from an S&T perspective, the research and engineering S&T strategy for DoD involves mitigating the threat through technology, recognizing we have to do that affordably. But as part of that innovation, surprise is key. And this has been a mantra of DARPA over the years, is to not be surprised, but surprise our adversary. Well, DoD has really captured that in terms of the S&T strategy as we go forward here. There are a number of initiatives, recent initiatives that exist. Things such as rapid prototyping to experiment with various configurations and uses in the field, get the technologies transitioned as early as possible. Another aspect of our R&E strategy is globalization. Because of this tyranny of distance, we really have to reach out across the globe to establish partnerships, leverage as best as possible from international partners, also rely on them across the world. As part of our job in OSD, we are to facilitate the management of the S&T portfolio across the board. Next chart, please. Okay, and how we do that is captured in what we call Reliance 21, which was stood up in the 2009 time frame by, at the time, Principal Deputy for Research and Engineering, Mr. Al Schaefer, who has since retired. Reliance 21 really involves coordination of our S&T portfolios across the services, as well as a communication tool to our stakeholders, those stakeholders being obviously our warfighter, Congress, and the public in general. Next chart, please. Within that Reliance 21 process, key to the implementation of that are what we call communities of interest. These are families of technology areas The same DNA flows through the blood of each of the individuals in these various communities of interest, of which there are 17 across the board, across our S&T portfolio. Next chart, please. The Air Platforms community of interest, which is what I support, embraces all platforms, all air platforms. Next chart, please. The APCOI, as we call it, Air Platforms Community of Interest, is divided into 4 sub-areas: fixed-wing vehicles, rotary-wing vehicles, high-speed hypersonics, which are all platform-related. There are unique aspects to these various platforms. Then propulsion power and thermal really is pervasive across these platforms and supports all three of the platform context sub-areas. Next chart, please. Okay, focusing on rotary wing vehicle, and which is fairly consistent with all the sub-areas in the APCOI, we really look at what are deliverables, what are the needs out there. So we always have these visions of where we need to be near, mid, and far term. And you can see in the chart that right now we're looking into ensuring that sustaining our current fleet is high priority. But as we move forward, future vertical lift is out there in the future. There's something you see there in the future, which is autonomy. Autonomy or unmanned systems all play into this. How innovative can we be with respect to this new technology area? The fact that someone can go to a hobby shop and buy a quad rotor for $500 or something like that. Is there something to being able to capture this advancement in technology and apply it to the warfighters' capabilities? That's something we're looking into now. Next chart, please. So I'd like to show a little bit about the technology taxonomy from the Army's perspective. And if you could just take a look at the various taxonomies there for the Army, you see such areas as degraded visual environment, higher range, longer range, higher speeds, et cetera, across the board. So these are the areas that, at least from an Army perspective, we need to focus our S&T on. The Navy has unique challenges as well. Across the services, we coordinate the S&T technology portfolios into, next chart, technology area roadmaps, which you see as the technology roadmap for the rotary wing vehicle sub-area. And those taxonomies that you see down the left column are consistent with what you saw in the overall vision of, from an Army perspective, where you're going. The other panelists will talk about some aspects of these technology areas. Future vertical lift is key to it. It's what we look for towards the future. But besides future vertical lift, we also have to address sustainment for our legacy systems. Okay, next chart. So in summary, I just want to say that S&T is a high priority as part of our research and engineering strategy for the Department of Defense. In these austere environments, we're going to have to address affordability. That's absolutely key. We manage these portfolios. We oversee them through our communities of interest. And obviously, from a warfighter perspective, the S&T innovation and for vertical lift capability is essential, not only now for our legacy systems, but also for our future vertical lift systems. Thank you.
Well, thank you, Joe. Ned?
Good morning. Thanks for the opportunity. Excuse me. So as it stands right now, we have some of the best aircraft in the world, rotary wing aircraft. As old as they may be, they're still as good as is available across the planet. But there are needs of our fleet that cannot be addressed with the fleet that we have today. Those things include increased speed and range. Things that are integral to achieving those are reducing drag, carrying what you carry inside the aircraft itself, and then being able to operate in just about every single kind of environment. So because the things that we're doing, planning with FVL are so different and so much more aggressive than what we can currently do, it's going to demand that we invest in technologies that allow us to achieve these different capabilities. And while FVL does not have a devoted budget for S&T, there is a dependence on the enterprise, as was discussed by Dr. Deutschek with the communities of interest, that are going to have to be addressed, things that we're going to have to collaborate our knowledge and our expertise and our investments to achieve the capabilities that are demanded by FVL. So to this point in time, our fleet has been a helicopter fleet. And with the late arrival the later arrival of the V-22, there are things that are required for investment that we have not invested in before in order to achieve some of these capabilities. Next chart, please. So our means to bring this FVL enterprise together is through the FVL S&T IPT. And the most important thing on this chart is to look at the different entities that make up our S&T enterprise. So from an enterprise perspective, the S&T enterprise is organized to deliver specific technologies. Maybe it's munitions, maybe it's tank and automotive kinds of technologies, maybe it's communications gear, maybe it's missiles. There is an entire enterprise out there that develops technologies such as these. And it includes the services. The Army has its Research and Development Engineering Command, of which aviation and missile is a part. The Air Force has a similar, or maybe a similar but a different kind of structure. The Navy includes ONR and the Office of Naval Research, as well as NAVAIR. So there is broad participation from the community, and our objective is to seek the collaboration of these entities to pull together the elements of technology that are required to deliver an FVL. And you might think, well, there's probably overlap in some of these technology areas, and there is. And as was mentioned as a part of the communities of interest, one of our objectives is to put together a plan, and that plan includes roadmaps, and those roadmaps focus on specific technologies that require some sort of development in order to render a mature capability. Next chart, please. So just briefly to show how the S&T IPT falls within the overall FVL structure. It is one of 4 primary S&Ts within the FVL structure. There's the commonality, the acquisition, and the requirements IPT. All are led by different organizations. But at the end game, the exciting part about this is that we're working together at the same time through a constant dialogue to make sure that from an S&T perspective, there's an understanding of the capabilities required, and we can deliver what we learn about those capabilities and the technologies required to achieve it, to discuss value and affordability with our acquisition community. So it's very much an integrated process. We report to an FVL executive steering group, and organizationally, it's been a very clean cut and a very decisive way to try to do business for such a comprehensive kind of job. Next chart, please. So our overall S&T objectives are try to deliver enabling technologies. Those are the things that are highlighted as high potential kinds of technologies that would afford these higher speed, longer range, reduced weight, own the weather and own the night kinds of technologies. Now, it can't be done all in one place. There are configurations that are worth considering, as well as technologies, as well as different capabilities. So blending the right mix of technologies to achieve capabilities and through the right configurations are critical to the success of the enterprise to be able to provide an air weapons platform and an aviation weapons system that is a complete weapons system. One of the other things that has been very beneficial from an S&T planning perspective is the engagement of the aviation rotorcraft industry and the entire defense industry. That has been very key to the efforts that we've developed so far, and it'll be very critical in our way forward. Next chart, please. So just as a description of the enterprise, of course, there's the services, the Army, the Navy, the Air Force research labs. There's the Office of Secretary of Defense Communities of Interest, as was discussed previously. We leverage what NASA does. We're in constant dialogue with DARPA, and we want to understand what industry is doing also, because we don't have a lock on all the good ideas by ourselves. So there's significant dialogue that's ongoing through every step of our phase. We're very excited to participate on such a broad scale, and as you might imagine, it's pretty difficult to herd engineers of that many organizations into a common mindset. Next chart, please. So our path forward. Our objective from an S&T IPT perspective is to lay out a roadmap of available technologies and to leverage what the enterprise is already doing and making investments in relative to technologies of interest to FVL, whether it be platform technologies, engine technologies, weapon technologies, antennas, radios, communication kinds of equipment. We want to put together a roadmap of those things that are out there and then make a judgment of that roadmap. Is it complete? Are there things we need? And then we want to run that roadmap by industry. We want to leverage not only what they think in the way of a systems mindset, but we also want to approach it with the ability to add technologies along the way or to consider things that maybe we haven't thought about in our traditional way of thinking. We want to develop that enterprise plan. We want to deliver that plan. We want it available for everybody to see so that they know what our investment plan is going to be. We want to make sure that those plans among the different organizations and the technology areas are complementary to one another. Excuse me. We want to evaluate technologies that we haven't looked at before, things that are beyond the helicopter realm, things that get into the aircraft configurations that generate speed and higher lift and greater performance and environmental capability. We want to research things that we haven't researched before because we're not bound to a lower speed regime. But most importantly, we want to leverage the talents of the entire enterprise, because there's a huge enterprise out there. It's very significant for us to leverage not only the ongoing investment and technology efforts that continue, but also the subject matter experts and the engineering expertise that's available to us, trying to harness that into a common mindset for FVL. And I believe that's it for me.
Thank you, Ned. Mike.
Hi there, I'm Mike Fallon. I'm from the Navy. I do have to tell you that my views today are not necessarily represent the views of DOD or the Navy. Let's get that out of the way. Thank you so much for having me today, the invite. I feel honored to be up here among this panel. It's really a kick for me. But one thing I'm a rotorcraft believer. I was an operator. I was in a naval aviator way back when in Desert Storm. I know what rotorcraft can do. I know their unique capabilities, and I think we can expand them. I think rotorcraft are the future for all sorts of purposes, both for defense purposes, for humanitarian purposes. I think we can go even further. So I'm here. I'm an advocate for rotorcraft, and that's part of my job. I'd like to read you one thing, a quote, if I will. The Navy and Marine Corps are participating in joint future vertical lift efforts to identify leverage points for future rotorcraft investment. In fiscal year 2015, the Department continues to modernize vertical lift capability and capacity with procurement of Romeo Sierra H-60, AH-1 Zulu, UH-1 Yankee, and MV-22 Bravo, and the continued development of the 53K and VXX, which is the helicopter or the presidential replacement. This was stated by Admiral Grosskлагs and General Schmiedel before the Senate Armed Services Committee last year, and I think it still holds true today, that we are committed to future vertical lift. One of my titles up there is the NAE. What that stands for is the Naval Aviation Enterprise. And what is the Naval Aviation Enterprise? It is all aviation within the Navy and Marine Corps. The users, the acquisition folks, NavAir, it's the requirements and the resource sponsor at OpNav, it's the Air Boss, it's the DCA. We're all part of this. When we do our research, we have a document called the Science and Technology Objectives document. All of those leadership folks sign this, okay? And this is the direction the Navy wants to go. This is to address the gaps in our rotorcraft programs, actually in all naval aviation. But that'll become important later. Next, please. So as a POA, I report to Admiral Janes. I'm her advisor for S&T for rotorcraft. She has another one who does anti-submarine. But as you can see up there, her portfolio is very broad, and most of the rotorcraft do fit in it, except for unmanned rotorcraft. I do have interaction with those folks quite a bit, and when there's an airframe type issue, they do come to me. Next, please. What I'm going to show you is a slide for each program, and what it's going to show you is a mission statement, what's important to the fleet for that aircraft, what the capabilities are, and as you can see, they're broken down into the now, the present capabilities that we're looking at, the emerging capabilities, which are sort of midterm, and then the future capabilities, and that's where I think FVL probably fits. You also see a list of the aircraft models in there, the number that are in the fleet, and their associated missions. And then you have some small things in there. So I'm not going to cover these in detail because I don't have enough time. I wish I did. But like for the H-60, that is the Navy's helo. They've got some very important missions looking for subs, small boats attacks, and GPS-denied environments. Those are very important. If we can go to the next. PMA-261, that's the H-53K program. And of course, the H-53K, if you haven't heard, had their first flight on Tuesday. And congratulations to that team. One thing I would like to say, every one of these aircraft programs is not just a NAVAIR program, it's a NAVAIR with a contractor as a team. So the H-60 was Sikorsky NAVAIR. This, of course, is Sikorsky NAVAIR with the H-53. The H-53K, as far as our program record, about 200 aircraft we're going to get, increases our capabilities amazingly. And as you can see, there's some things up there the Marine Corps are very interested in, survivability. Digital interoperability, I don't know if you know what that is, but that's every sensor can be connected to every other aircraft, could be unmanned, could be manned, but we can see the entire operational picture and get the information to the right person at the right time, almost real time. That's our goal. We'll see if we can make it. Next, please. Of course, 275 is the V-22, teaming up with Bell Boeing team there, and I think that is really broadened the minds of the Navy and Marine Corps. In fact, the Navy likes it so much, we've bought it. We're going to buy it for carry-on-board delivery. That's a very new thing. You can see in the lower right, there's all sorts of missions and capabilities that we're looking at we're not even doing today, but they're in our minds. The capabilities of the V-22 keep on expanding. It's a wonderful platform. We're still figuring out how to use it, and I think it's going to go even further. Next, please. PMA-276, that's the Cobra and Huey. We're just finishing up the buy of our Yankees, and our Zulus are just coming into the fleet right now. Great capability upgrade for the fleet on those aircraft. Much more speed, range, weight capability. The fleet is very pleased with it. Next, please. 274, this is presidential. This is executive transport. Right now we have the VH-3 and the VH-60, and we're going to be going to the VH-92. What's unique there is this is going to be a commercial off-the-shelf type acquisition. We're going to try to keep the FAA cert as long as we can to reduce costs, reduce acquisition costs, and that's a huge thing for the government. Let's give the taxpayer their best dollar. Next, please. And here's joint future vertical lift. It's certainly collaborative. We're in it 100%. The Army's taking the lead with the JMRTD, but our NAVAIR technical experts are helping out. We're going to the same meeting as they are. We're helping out with V-22 data. And I think the big thing here is our people are one of our biggest resources. Their experience they have, the technical background that they have, and what they've seen in the fleet. Our V-22 experience has shown us what something that can go high and fast and far can do, and still be able to land and take off vertically. As far as the FVL, we're involved with Ned on the S&T IPT. That has been amazing for us because we're getting our research experts together with the Army research experts. We're combining our portfolios for an FVL, and we're looking at our portfolios put together, say, hey, we may have some weaknesses here, or hey, you guys are doing a little bit better there. It's getting a really good one picture for the DOD, and I think we're going to get our best bang for our buck there also. And we're constantly learning from this process. And as you can see up there, the Navy is right now the lead of the Common Systems IPT. We're working on things like FACE and JCA, trying to get the plug and play that you may have heard of. We can go to the next one, please. So what's our near term? If you look up there, there's a lot of things up there, but really supportability and reliability are the near term alligators out of the boat. And I think that's true for any aging aircraft or any aircraft that you have. we need to keep going with the software, the logistics, the equipment. We need to keep all the costs down, but keep the reliability up for the operator. Next, please. So as far as future technology needs, I think that this fits in well with future vertical lift. Integration and interoperability amongst the manned and unmanned platforms and surface ships is certainly one thing that we're looking for, both across the Navy and Marine Corps. Digital interoperability, the network battle space is something that I think that we all agree is something that we need. Degraded visual environment for us is as big a deal as it is for the Army. Of course, with us, we're really concerned about going to a ship. Survivability, the threats keep on changing. We got to respond to them. Enough said there. PNT, what happens if the GPS gets denied? We need to figure these types of things out. Structures and materials will always be something we're looking at. Let's improve the structure, make it lighter, stronger, and able to carry more. Additive manufacturing, we'd love to be able to print parts on the ship. That's a really small supply chain there. If you can take your basic material and print a flight qualified part right on the ship, that's great for the Navy. Fusing data, that's part of the digital interoperability, and open systems, software modularity, that's something that we want to. As far as something that's not up there, but O&R has a sea-based aviation thrust. We consider the marinization and going to the ship as one of the unique capabilities of the Navy, and we're investing quite a bit of research into that. How do we do all this? We partner with you guys. We partner with small businesses through SBIRs, academia, STTRs, future naval capabilities, rapid innovation fund type programs, and things like JMR and FVL. And next, please. And that's all I have. And questions will be at the end. Sorry.
Well, thanks, Mike. And last but certainly not least, Dr. Bagat.
Thank you, Andrew, for hosting me. I'm with DARPA, and I'm going to start by giving you a little bit of an overview or a perspective on DARPA's initiatives, specifically with respect to vertical flight. I will point out that the opinions that I state are mine, and I'm not speaking for the Department of Defense or for the agency, on behalf of the agency. But DARPA, as Joe pointed out, DARPA's mission is primarily to create technology to prevent technical surprise from adversely impacting the national interest, and also to create technologies to enable technical advancements and technologies that support the national security. DARPA's mission, therefore, enables it to look well beyond the horizon and to start enabling technologies or investigating technologies to enable new capabilities to probe the art of the possible. And that flavor is very much carried forward in its VTOL initiatives and programs that we run at DARPA as well. The timeline that you see over here dates back to DARPA's inception in 1958. And is a timeline of all major VTOL initiatives that have been undertaken through DARPA. And in some cases, these have been the development of systems, and in some cases, they are the development of capabilities to rapidly fill gaps that exist. And in many cases, they're to probe what future technologies may be developed to enable remarkable breakthroughs in vertical flight. What you see on the top right are some of the current programs that we're undertaking right now. VTOL X-plane being one of them, and there are some examples of images of some of the system technologies and that are being developed under that program, for instance. There's the other one called Turn is also looking at similar technologies to enable remarkable capabilities in support of the warfighter. These are very important from the perspective, as Ned also pointed out, that we've always had perhaps the best vertical flight fleet in the world. But if you can go to the next slide, please. I'd like to point out that there are some remarkable things that have started to happen. And here you have a timeline of vertical flight X-planes that were predominantly United States through the dawn of vertical flight. 1939 is when the first successful helicopter was flown in a controllable fashion. And since then, this is a spectrum of the different types of vertical flight machines that have been developed in the US. And they're representative, I think, quite nicely of what perhaps happened globally as well. In the decades following the successful flight of the helicopter, there was a large emphasis on trying to make them fly faster. And that's what you see in that gray bar over there in the 1955 to 1965 range. a very large emphasis on looking at hybridization, looking at new and novel concepts that could enable higher speed flight. Helicopters, edgewise rotors, as you know, are limited fundamentally by physics as to how fast they can fly. But those challenges that were presented by these aircraft were obviously very difficult to overcome. Controllability, efficiencies, a variety of different aspects kind of limited what we really were able to do. And perhaps to this date, with the exception of the V-22 Osprey, we really don't have anything that's a true vertical flight machine that is in operational status. Following those those few decades where we really had a lot of X-plane developmental work taking place at high-speed flight, we reverted to improvements in what I'll call dominant design of vertical flight, the helicopter itself. A lot of advancements made there, a lot of understanding of the fundamental principles behind that, a lot of tools to help with design methodologies and understanding and being able to experiment and improve efficiencies of the system to enable new capabilities. And those are some of the underlying initiatives that perhaps have led to us having some of the best vertical flight machines in the world. In recent times, though, we've started to see the evolution or the appearance of some very remarkable achievements around the globe. Our leadership in being able to produce helicopters is now being caught up. There are a number of very advanced capabilities out there, and there are a number of newcomers who are able to make very fine helicopters. Some of the notable global achievements that are listed up there include very out-of-the-box thinking as well, and while not all of them are necessarily driven by military applications, in fact, indeed, several of them are driven by civil or personal air vehicle designs and interests. But we're also starting to see a plethora of home-built concepts coming into the picture, starting to see electric propulsion becoming more than just a hobby. In fact, there are 3 at least electric propelled aircraft or electrically powered aircraft capable of vertical flight that have been developed, and these are actually home-built. There's been a proliferation of unmanned systems, and this has been enabled not only by software and computer systems, but also by advancements in control systems and flight control systems. And perhaps those were some of the limitations that some of the earlier initiatives that we looked at enabling in high-speed flight were limited by. And who would have thought that aircraft programs are being crowdsourced, and these are for manned aircraft applications. So we live in this world where today we've got this remarkable evolution or even development of technologies that is way beyond just innovation. In fact, indeed, it's perhaps, contains several elements of inventiveness. And this is where DARPA then comes into the picture in trying to not only fulfill some of the urgent capability gaps that we have today, but then to go out and start probing the art of the possible, as I said, to enable new technologies, to enable new capabilities. Thank you.
Well, thank you, Ashish. And thank you, panel, for those presentations and framing of our topic and giving us some of the content. Let me ask a couple questions, and I'll turn to the audience questions. But as opposed to the questions I had thought of beforehand, I came up with some while you were talking, because there was a couple of threads that I thought kind of ran through the comments. Joe, you mentioned that it's a challenging budget timeframe that we're in, which is very true, although knock on wood, maybe there will be some budget clarity, at least for the next 2 years, coming from the Congress. But it's certainly true that it's a very challenging budget environment. And I think most of you framed your discussion of your roadmaps as kind of near, mid, and far. And a couple of you mentioned that FVL might be in that far category. So I kind of wanted to pull the thread a little bit on what far means. Because obviously I was at AUSA a few weeks ago. We have these demonstrators that were on display in the big hall. And so there's a certain degree of concreteness to some of these technological approaches. And obviously with V-22 flying, that's very concrete. So I just would like to get kind of your reaction to what makes FVL something that's at the far end of the spectrum. Is it budget? Is it technology? Do we really have that far to go? And kind of get your reaction to that. So I don't know, in any order, anyone wants to jump in on that.
I would say, at least from the perspective that we've taken with the development of our S&T IPT roadmaps, we're trying to harvest technologies that will achieve a TRL of 6 by FY22 time frame. If you stop and think about the duration of the FVL family of systems is going to be very long, and so for the objective of our IPT is to try to provide the technology for the first out of the box. So if you look at an acquisition schedule that is, I guess at this point is still a bit fluid, it demands some sort of technology maturity by the early 20s. But that's not to say that that's where it stops. Because if we're talking about the technology development for the first out of the box, and that there will be other members of the family that will be coming along afterwards, the science and technology program is going to have to be persistent, because they're going to have these different aircraft will be of different sizes. They will have different mission sets. They will demand slightly different technologies depending on how their capabilities are described. So at the end of the day, at least from an S&T IPT perspective, I would not suggest that the technologies that we're looking for are particularly far term. I would say at furthest, maybe midterm.
Anyone else want to take a crack at that?
No, I would back that up and just say that that's a good way to put it, in terms of the nearer term potential applications for Future Vertical Lift program, which isn't a program of record yet. So by definition, that does not mean near term, I would say. But there'll be spin-offs of technology all the way through, mid through far term.
And I think sort of related to that, a couple of you mentioned, Mike, you mentioned about how you're still kind of in the discovery mode with the V-22, even though it's been in the fleet now for a number of years and is an operational system, you're still to some extent in discovery mode about what's possible with that platform and with what it brings to the table. And obviously, those of you who are in the S&T, core S&T business, you're constantly dealing with the fact that the things that you're doing are designed to enable really neat things in the future, but it's, because they don't yet exist, it's pretty hard to explain exactly what those things are. So how do you go through thinking about, Ned, you mentioned, being in higher speed regimes may open up entire new possibilities for technology possibilities that just haven't been examined because we haven't been operating in those flight regimes. So how do you go through thinking about, I guess making your best educated guess as to what those new capabilities might be so that you can guide your S&T towards them?
Well, I would say from an FVL perspective, that's the beauty of the way that the program is structured at this point in time, for the simple reason that we have a requirements community that's telling us what it is that they'd like to be able to do. And so given that our box has pretty well been shattered based on what it is that we've always done with these kind of aircraft, kind of opens up a whole nother opportunity for imagination. And so we're far less bound by history than we've ever been, simply because Ashish showed several charts that showed how these aircraft, X-plane kind of aircraft, have been developed in the past, and you'll see that a lot of these configurations have been revisited. Part of the reason that they're revisited is because there are technologies out there that can accommodate the things that those configurations didn't do so well. For instance, maybe they vibrated a lot, or maybe there was issues with either rotor blades or structures, or there were boundaries that we can now pass with the technologies that are available to us. And so if we make some sort of devoted investment into a speed regime that we've never been before, not only are we going to be able to refine what we've always done, we're going to discover things that make those technologies even more beneficial for a future fleet. And so that's an extremely important part of what we do, and it reaches back to what we've learned on the V-22 and given the type of configuration and the versatility that it has, and it bodes well for our perception of the things that DARPA is doing, because they're reaching a little bit over the horizon, and as they go along discovering things, we're able to benefit and leverage from the things that DARPA's investing in, even though the concept itself may not be quite as mature as what we would like to pursue from an FVL point of view. There are technologies that enable those concepts that go way beyond what we already have. And so to couple the thinking of the look ahead that DARPA provides with the infrastructure that already exists within the S&T Enterprise and the communities of interest, it just makes for an exciting time. It gives you a whole lot of latitude as to what to choose from and who to choose it from.
And if I could add, it is a fine line, because, you know, we have to convince the people who hold the money that this is a technology that will give them an added capability that is affordable, or it's so good that they're going to want to pay for it. If it's not good, they're not going to pay for it. So it's a fine line on how we do that. And like, you know, I'm both in the program office and in the CTO, so I can grab those technologies, and then I have to try to socialize them with the programs to show them what they are and what benefit they have. And if I can champion it with them and get their support, and when we do our projects at NAVAIR, we have to get program support, or else it dies. So it's a hard thing, but, you know, we only want the things that the warfighter wants and that the taxpayer can afford.
If I can just add a couple of comments to that as well. You know, the interesting thing about working in this kind of scenario is that the DARPA enables a little bit of a model inversion, as opposed to necessarily going after a reasonably understood or well-defined gap in capabilities. Sometimes we're able to go out and probe those frontiers of what is the art of the possible, as I said. And what's interesting about that approach is that yes, you do discover things along the way. I'll give you a couple of examples very quickly of what has happened in the execution of some of these programs that are on that map that I just showed you, as well as some of the potential applications of them. They're not all matured to the point of being developmental programs. DARPA likes to develop or prove things in X-planes to prove that they're possible, so that they can then be spun off or adopted or adapted. But you know, talking about certain elements of design methodologies. There's been a very concerted effort in our community to continuously improve and develop the tools that we use for design, and to make them more sophisticated, and to bring more sophisticated tools to bear so that we reduce our design cycles. And yet we have to verify our tools and verify the results that we get from our tools. During the process of running just the VTOL X-plane as an example, I think we've seen some significant improvements in applications of these relatively sophisticated design tools that have not necessarily been brought to bear in the past, but have now been able to reach a level of maturity that they can be applied for routine design purposes. And I'm talking about unsteady flows within you know, rotating machinery or rotor systems. But what's also interesting, the counterpart of that, is that there's always a need for empirical verification. And there have been elements of the program that have successfully applied novel and very rapid prototyping techniques to go into wind tunnels and verify that the tools are generating results that are believable, meaningful, and applicable. Now that, for example, also helps elevate the base, the industrial base, and the capability base of the community in a very important manner, because the quicker your design cycles, the less expensive it becomes to develop new and mature technologies. There are other elements that are being developed or coming into the picture. I mentioned briefly that some of the lack of successes that we may have perceived or had in the past on hybrid concepts that were pursuing speed was control systems. When you have a pilot in the loop and the pilot's workload goes up to the point where absolutely every aspect of aircraft controllability and sensitivity is being driven by a human being or two human beings in the cockpit, it becomes a very difficult thing to do. But with modern control laws, the ability to sense the state of the aircraft, to close those control laws, you can now start doing things with aircraft that you could never do before. We've seen that very, very successfully applied in the fixed-wing world. But we're starting to see hybrid systems that are highly over-actuated, that have control surfaces and a variety of control mechanisms that are, I wouldn't call them duplicative, but they are redundant. And that itself opens up a spectrum for control systems and for performance improvements. So here's just one example where we're seeing an immediate impact by pushing to the frontier of advanced VTOL concepts in terms of improving our capabilities in design, but we're also opening up the space for further probing and further investigation and enablement of capabilities.
Thank you. Let me turn to our audience here. We have a distinguished group, and I would like to get in some audience questions. So here in the, always like to reward someone from the front row. They're going to bring you a mic. That's why I said it.
Hi, I'm Richard Whittle. I'm here for BreakingDefense.com. This may be a question for Mr. Chase. I'm not sure. The improved turbine engine program is the Army's top aviation priority, I understand right now. But the engines, the engine that results won't be in full rate production until, I think, 2027. So is that engine maybe by default going to become the future vertical lift engine, the joint multi-role engine? How does the ITAP timeline and the JMR FVL timeline, how do they mesh? Or do they not?
Well, I would say at this point that that's probably too soon. It's probably too soon to know that, simply because I think there's different capability sets being considered from an FVL perspective that would dictate probably the size of the aircraft, whether or not the size of the aircraft would demand an ITEP size or ITEP horsepower engine versus maybe a larger engine or even a smaller engine. At this point in time would be, I think it would be very premature to say, and certainly not a question for an S&T guy. What I can say is, from a joint multi-role technology demonstration program, we have selected engines, and the power requirement for the aircraft that we spec for the demonstrator aircraft is significantly higher than ITEP. So we're leaning on we didn't want to develop a demonstrator and have to develop an engine to fly it. So we tried to make use of engines that were already available for that. So I would say ITEP relative to FVL, at least from where I sit, that's probably way too early to call. And from a JMR TD perspective, we're actually doing what we're doing with engines in parallel. For one of the aircraft, it's basically a CH-47 engine, and the other one, it's a CH-53D engine. And one's a T-55, and I'm not sure exactly what the nomenclature. Excuse me?
T-64.
T-64. Thank you, Dave.
Hi, James Drew from Flight Global. 2 points to come out of AUVSI with the demonstrators that were there. One is that for every $4 industry is spending on this demonstrator program, the government is spending $1. Plus also there's concerns about how long the timeline is for that. Industry would prefer to see something more like 2026 or 2027 for IOC. What's the government's view on those two things? And just that kind of unsustainable industry input.
Okay.
It's a program. That's why you're in the middle.
It is. I'm not sure I understood the whole question, but I think the gist of it was the industry has indicated a preference maybe to accelerate FVL to get it into a shorter time window. Is that what you were suggesting?
Yeah, and also that they're putting in too much money.
Well, they're putting in a lot of money, and I can honestly say that from an S&T perspective and our JMR Technology Demonstrator program, industry has invested $3 for every government dollar that's involved there. So it's a heck of a bargain for the government, and we've changed the way that we do business to account for the fact that they're investing so much of their own money, and surely we're the beneficiaries of that. As far as pushing back the FVL timeline, I think that's always a consideration, because I think there's probably a belief that the shorter the acquisition timeline, the more money you can save. I think that's probably offset by a little bit, maybe by how much money you have and how much is available to you. So I would suggest that the FVL, the willingness to try to accelerate FVL acquisition, there is a willingness to try to do that. Whether or not that can be accomplished within the funding constraints that are out there right now is really kind of hard to say, and it's maybe better asked to somebody in the acquisition community.
And really, it is going to depend on the programs of record and when they sundown, if they're going to extend the lifetime of the airframes, or if they're going to look for new airframes, and that's something for them to decide.
Let me ask another one on the mix of investment, because obviously for the portfolios that you've laid out, at least those of you who have programmatic portfolios, investment portfolios, there's a mix there. You're looking at technology, most of which probably be relevant to FVL, but many of which could be relevant to the existing fleet. So I'm kind of interested in how you see the balance of inserting some of these technologies into the existing fleet, and maybe how do you decide whether to focus your tech development towards that objective vice focusing it towards investing in things that are going to wind up as part of FVL?
I could take a crack at that with respect to our current portfolio, and it's roughly 50-50 technologies that are aligned with FVL versus legacy systems right now. It's not necessarily designed that one has to do that, because every technology area has its different thrusts, its different emphasis areas. Just so happens that's the way it is right now. Is that the right answer? Who's to say? All we know is that we try and provide the capabilities that are needed, and if there are gaps, then we have to prioritize those gaps in technology needs and try and reprioritize the technology investments. So that's one way to look at it. Another way to look at it too is what we call budget activity, which is associated with technology maturity, we'll call it. Are we talking about demonstrations of existing or more advanced technologies, or are we talking about truly developing new technology? That also is roughly 50-50, but that will cycle with, with periods of, for example, ITEP is an example where it's time to mature existing technologies to a higher level. So that changes the balance of the portfolio towards more demonstrations than technology development.
And if I could answer that too, I mean, like I said before, it's going to depend on each program and when they're going to hopefully or decide to either upgrade their aircraft, extend it, or get a totally new one, and that's through the normal acquisition process. And a lot of what's going to guide that is what sort of budget we're going to have at the time. That's a huge determining factor. Everything I showed up there as far as capability roadmaps are for the programs right now. So we're taking all those, we're looking at them, we're seeing what would apply to FVL. Now, in theory, if an aircraft program does decide to go to a newer aircraft, that could be an FVL aircraft. We'll see how this plays out.
Well, I would just kind of follow up on that. We had a discussion with some Air Force officials I won't name here yesterday, and it was brought up a couple of times that the Navy's investment in aviation in the last several years has been actually higher. They've been acquiring more new aircraft than the Air Force has been, which is interesting, probably a good development from your perspective. It's also true that because that is the case, that the Navy's fleet, with the exception of the C-2 that you're looking at V-22 to replace, it's a newer fleet, right? It's not, it doesn't have the age that you see in the Air Force fleet. So presumably that's got to influence the way, when you talk about future programs, a lot of these aircraft are relatively new.
That is true. In fact, the H-60, I believe that the production line is closing down either this year or next year for our Navy. They're going to be selling them foreign military sales. You're right. I mean, each program is looking at their future, where they're going to go, do they need to do SLEPs or SLAPs to extend the airframe, or do they want to look at a new airframe? And that's part of the acquisition process. I believe that you're right. The Navy is pretty healthy. Most of those airframes I put up there are relatively new, within 10 years. I believe that the V-22 may be one of the oldest ones in the H-60, but they're still relatively new, looking at what the other services have. And and if you add in the rest of Naval Air, like the JSF and all the unmanned programs we have, we're doing pretty well. Does that mean we're not looking towards the future and future upgrades and replacements? No, we're certainly keeping our eye on what's going on.
And let me ask, Ashish, you talked a little bit, it was brought up that there were some barriers that have been issues for past X-plane efforts, and that, the technology was demonstrated, but there was some technological issue or some barrier that needed to be overcome to make that really practical. And I'm just curious if you would feel comfortable, maybe, and you talked about control laws, as it sounded to me like that might be one area of being able to just manage a really complex flight control regime that maybe in the past you couldn't do. Now with today's technology you can. Are there other areas where we're seeing, and you also mentioned electric propulsion, are there other areas where you see that these kinds of breakthroughs, that past concepts can now become much more practical, we could think about?
Andrew, I think there are. I think there are quite a few, and in fact, I'll give you a sampling of a couple more. There are fundamental differences between the requirements for high-speed flight and wing-borne flight versus hover capability. And I think one of those limiting factors in the past has been, how do you do both efficiently, or can you even do both efficiently? So there are examples in the current portfolio that are serving to address those kind of issues, and some of them are being enabled just by the maturation of design methods that we have, because we're able to do this by design, deliberate design, as opposed to settling for an outcome. There's a vast history of knowledge base that's been developed, and there's an understanding of perhaps what needs to be done in a somewhat more astute manner, so that the targets that we're going after are better understood, as opposed to just becoming fallouts and settling for what you get. Being able to hover efficiently and maintain a duty cycle in hover, and yet to be able to transition into flight, into wing-borne flight or forward flight, and fly efficiently at higher speeds in forward flight are two diametrically opposite tension creators that we've been able to address more successfully now. As an example, weight empty fractions have always plagued us. That's a big part of it. Now, I wouldn't necessarily say that we've made remarkable changes to our weight empty fractions at this instant in time, but we've certainly tried to preserve the state of the art in terms of utility and useful work capability. These are some of the items that we've not been successful in doing in the past. Indeed, even in comparison to contemporary X-plane programs of the recent past, I think we're in a better position right now to try to retain the usefulness of these aircraft, even at an X-plane level. So I think those are some of the achievements that have been made that are in addition to the control systems.
I guess I'd like to also add, what's your perspective on additive manufacturing in terms, or manufacturing technologies in general, in terms of potential capabilities that might provide?
So I'll answer that with one word. I think it's absolutely awesome. Primarily because I think we've seen some of that in our programs as well, Joe. I think you bring up a really good point. Building really complex shapes with the strength and the structural requirements, the stiffness properties that are required for airframe structures, are truly starting to become enabled by some of these techniques. We have seen the application of 3D printing to flight machines during the course of this program, and I don't think that some of the things that we've been able to do with 3D printing would have been possible without it. So from that perspective as well, I think, Joe, thanks. I think you bring up a really good point.
I have time for one last question here. You want to bring the mic?
One of the roadmaps that was presented at the beginning spoke about zero maintenance as a kind of 2035 vision, and I was curious to know what are the realistic expectations and investment opportunities in that area?
Yes, that's captured on the roadmaps. We're looking at what are the technologies that are necessary to address the key cost drivers across our systems, and operations and support, maintenance, et cetera, is highest. You know, development and acquisition costs are one thing, but when it comes to overall life cycle costs, O&S costs still trump everything else. So it really is, what can you do from the overall design perspective to design in low maintenance costs? And back to what Ashish described in terms of design tools, materials manufacturing technologies, et cetera, all of that needs to come into play to be able to work towards a goal of zero maintenance. If we ever got there, that'd be great. You notice it's a long-term objective, but right now we're just looking at the what feeds into that to try and achieve that goal as best as possible.
I think that's a big goal for the Navy also. Even though we have newer platforms, we still do have older platforms. Even those newer platforms are very expensive to operate. You know, we want to get the operation costs down, maintenance costs, cost to fix them, all those things.
Well, let me thank everyone for joining us today, and please join me in thanking our panel for a great discussion.